Every second, thousands of GPUs are running machine learning workloads across the world's largest data centers, and the people responsible for keeping them running are flying blind. In managed cloud and high performance computing environments, infrastructure operators cannot see inside the workloads they host. They can't read the model code, they can't inspect the training loops, and all they have are hardware sensors, a few including CPU utilization, GPU power draw, memory pressure, and network traffic. And when a performance is bad or something silently fails, they're stuck staring at a wall of raw metrics with no way to know what actually is happening or why. But here's the thing, the hardware always knows. Every GPU bottleneck, every memory stall, every network burst leaves a fingerprint in the telemetry data. The question is whether we can read those fingerprints without ever seeing the workload itself. InfraScope answers this question. We take raw telemetry from over 4,500 real machine learning workload runs, 100 gigabytes of 100 millisecond sensor data, and convert it into a symbolic language that data mining algorithms can understand. We then mine that language for three things: what hardware states co occur, what order they follow, and whether training and inference leave distinguishable signatures. What we found is critical to machine learning telemetry analysis. First, over 90% of GPU bottleneck patterns cross hardware boundaries. For example, a GPU stall almost always predicts something specific about CPU and network state as well. Second, nearly half of all training patterns are temporally ordered. The sequence matters, and co-occurrence analysis alone misses this. And finally, clustering algorithms with zero knowledge of what workload is running are able to correctly identify training versus inference 89% of the time, purely from sensory data. InfraScope turns a wall of hardware noise into actionable, phase aware, bottleneck intelligence. The hardware was always telling the story, and we are finally listening.